Welcome to the NPTEL course Control Engineering. I am Teja Golla, a fifth year research scholar working under Dr. Santanu Kapat at Embedded Power Management Lab, IIT Kharagpur. These are the problem solving sessions of the NPTEL course Control Engineering, where I'll be summarizing the concepts that Sir has covered in that particular week, and I'll also clarify your doubts. Along with that, I'll solve few problems so that we can understand the concepts better. Let me share my screen. I'll quickly introduce myself and then we'll start to the today's discussion. Can you see my screen? Can anyone please confirm?
Yes, sir. We can see your screen.
Okay. Yeah. So welcome to the course Control Engineering. This course is taken care by Dr. Ramakrishna Pasumathy and Dr. Mausami Mukherjee. And I am Teja Golla. I'm a fifth year research scholar working under Dr. Santanu Kapat at Embedded Power Management Lab, IIT Kharagpur. So I'll just give a brief introduction about myself before we move to the purpose of these sessions. So I am currently pursuing my PhD in the Department of Electrical Engineering. I have completed my bachelor's from IIT Kharagpur in 2021, and then I have converted to PhD. My specialization is control system specialization, and I have done my summer internships in Xilinx during 2020 and Qualcomm during 2022. And this is my education as well as experience. And I have done my bachelor's under Dr. Santanu Kapat and then continued to PhD. So all these links I'll be uploading to my Google Drive. So you can contact me on LinkedIn or you can directly mail me if you want to connect with me in the future or if you have any doubts regarding this course. And I am also sharing my website. Through that also you can contact. And these are my details. Coming to this course, Control Engineering. So this course is of 12 weeks where we will be learning various fundamental concepts of control engineering like Bode plot, root locus, etc., which are very crucial. Even if you are from EE background or EC background or aerospace background, controls are everywhere. So one should have the fundamental knowledge of controls so that they can apply in any background, like whether they're coming from electronics, communications, or aerospace. Control is very crucial and sometimes very critical in certain applications. Like in the case of aerospace, aircraft, controls are the key because if they are maintaining a particular speed or if they are maintaining particular altitude, so that has to be controlled, the height at which the aeroplane is flying or the speed of the wings. So there has to be a control which will ensure the speed is controlled or the altitude is maintained. So in such cases control becomes very critical. So I'll just give a brief outline of this course. It has 12 weeks. So now currently we are in the week 1, which is mathematical modeling of the systems. Week 2 is about Laplace transform, transfer functions and block diagram representation. Week 3 is about block diagram reduction and time response characteristics. Week 4 is introduction to stability and what is Routh-Hurwitz stability criterion and how it can be used to judge about the stability of a given system. And then we'll discuss about the root locus as well as stability margins in week 5. Then we'll move to the frequency response analysis, Bode plots, Nyquist stability criterion, and how stability margins are defined in the frequency domain. So we'll start with the time domain, then we'll move to S domain, and then we'll move to the frequency domain. Coming to week 7, we'll learn about the basics of controller design as well as the PID controller, the proportional, integral, as well as derivative actions. Then we'll learn the design using root locus. Then we'll learn using Bode plots. So this is S domain, this is frequency domain, how we are going to design using different type of approaches. Then we'll also see what are the effects of zeros on the response of the system and what are minimum and non-minimum phase systems. And in week 11, we'll learn about the state space analysis, and then we'll also learn the design using state space. So this is the content of this course, which will be taught by those two professors. And I am the TA who will take care of the problem solving sessions. So what you can expect from this problem solving sessions. So first, I'll be revising the relevant theory in that particular week. So in week 1, I'll be revising the concepts that sir has taught in week 1, and then I'll also clarify your doubts if you have any. Then we'll start solving some examples using which we'll try to understand the theory and how it can be applied. So as we proceed, you can always ask questions from the previous weeks because everything will be connected. But if you have any doubts in the upcoming weeks, we'll just hold on to it so that we'll discuss in that particular week because others might not go through the lecture videos. And one thing I would like to clarify at the beginning is these problem solving sessions are not a shortcut way to prepare for the exams. You must go through the lectures that sir has taught, and this is mainly for problem solving sessions. However, I am revising the theory so that you can better understand the theory, and I'll also be clarifying the doubts. So this 2 hour session is not to teach again what sir has already taught. Rather, this is a summary session of what sir has taught and more of problem solving sessions. So it would be beneficial for both of us if it is more interactive so that you can also ask doubts and solve problems along with me so that everyone will get benefited. So consider this as problem solving session as well as doubt clearing session. It is not a teaching class. So coming to the session details, this session will happen every Monday, 6 p.m. to 8 p.m. So from today till 12 weeks. So every Monday there will be one session, 6 p.m. to 8 p.m. By any chance, if I'm unavailable, either I'll be preponing it or postponing it, and the meeting link will remain the same. Please save this meeting link with you yourself so that you can always join. And if there is any change in the meeting date or timings, I'll contact the NPTEL team and then they'll mail you regarding the updated timings. All these sessions are recorded and then they'll be uploaded to my YouTube channel. Here is my YouTube channel. Link I'll also mention in the chat box. And all the notes, these slides, whatever I'll be discussing in that particular week, I'll be uploading it to my Google Drive where you can find the PDF copy of the notes. So this is the basic introduction about these sessions, what these sessions are about. Now we can move to the week one content. If you have any doubts at this point of time, you can ask. Any doubts, anyone? Hello. So if you have any doubts till this point, you can ask me. I'm also sharing 3 links in the chat box. Kindly keep these links saved somewhere. So first link is my YouTube channel where I'll be creating a playlist and I'll be uploading this problem solving session for this course. Second is the link to the Zoom meeting. The meeting link will remain the same throughout this entire semester for this course. So you can join this Zoom meeting using this link, and it will be on every Monday 6 p.m. to 8 p.m. unless it will be changed, and even if it is changed it will be mailed by the NPTEL team. And the drive to the notes I have not yet uploaded, but that is the drive where I'll be uploading all my notes. So can anyone check and let me know whether you can access all the links and whether they're working? Just kindly check these links and let me know whether they are working or not. uh, I'll be uploading the video within 24 hours once the session is over to my YouTube channel, and I'll also be uploading the notes along with the video. So once the video is live, you can find the notes in the drive link I have shared. So can anyone please confirm whether you are able to access the links? So once that is done, we can start the session. Working, sir. Okay, working. So if you have any queries until this point, you can ask, else we'll start the session. Okay. If you don't have any questions, then I can start this session. Yes, sir, YouTube is working. Okay. Thanks for confirming. Uh, if you would like to introduce yourself, you can mention in the chat. I have introduced myself. So I would like to start with system. So we call something like plant or system, right? So what is system? System is anything. If you give input, it will give some output. So system can be considered as a block. So I hope you are able to see my screen where I'm writing. Yes, okay. So system can be considered anything. So you can consider your air conditioner as a system. So I'm giving input through my remote and the output is the temperature. So I'm giving some excitation and I'm getting some response. So it can be considered as a system. Your laptop can be considered as a system. I am giving some input through my mouse or through the keyboard and I'm getting response in terms of Windows or whatever software I am currently using. So I can consider system to be a box and the overall objective of the course is to understand the dynamics of the system, to model the system, to check the stability of the system, and then to design a controller for the system and make sure the overall closed loop works in the way that we would like it to be running. So first I'll be discussing about the nomenclature, which is very important. So we have input. Input is also called as excitation. So for a given system, we'll give input and then we'll check the output. Output is also called as response. So any system that gives output to a given excitation can be modeled. And for this session or for this course, sir has considered several examples of systems starting from electrical system to mechanical system. We would like to cover both the examples, electrical as well as mechanical. But as we proceed further, we'll be sticking to only electrical examples because this is from E background. So we'll cover different type of systems, trying to correlate our knowledge with all the systems that are available. But as we proceed, we'll consider more of electrical as well as mechanical systems. So coming to the nomenclature, which is very important. So not just this course, any course, there is some universal nomenclature that people will follow, and we need to also follow that as like the strict nomenclature so that there will not be any confusion. So there are some variables and then there are some notations. So let us mention it today itself so that there will not be any confusion in the future. So we have variables and then variable names. And then we have symbols. So time, so time is named as T, and then input, sorry, and then we have input, which is U of T, and then we have output, which is Y of T. And then if there is any delay, time delay, it is mentioned by delta. And then any disturbance is there in the system, it is mentioned as W of T. And if there is any function, we call it F, G, H as the functions. So these are the nomenclature that we are going to follow throughout this course. So whenever we consider U of T, it is input. Whenever we consider Y of T, it is output, and delay is delta. Time is known as T. So there are different systems in our life. So anything can be considered as a system, as I have just mentioned. AC, mobile phone, our brain is a system, our hands are a system, So if we are moving our hands, we are sending signals using nerves, and then hand is moving. And then we are taking the feedback from our eyes or nose and ears, and then we are making sure the hand is going in the certain direction. Say we are trying to pick up a bottle from a table, our eyes are acting as a feedback. So the eyes are telling that now I have to move my hand towards the right or towards the left so that I'll know the location of the bottle. And then brain is sending the signals to the hand so that the hand will reach the bottle, and then I can hold the bottle and then I can take. So hand is a certain system. So whatever we are seeing in our day-to-day life, car is a system. If we are pressing the accelerator button, then the car is moving, and then again we are the feedback. We are taking the information whether to move left or right, or whether to go a higher speed, or whether to use a brake, and then we are giving the signals to the car mechanically using the pedals, brake pedal or accelerator pedal or clutch or gear. And then the car is the like system that is moving, and it is responding to whatever inputs that we are giving. So there are various systems in our day-to-day life, so we need to also categorize which systems are linear, which systems are non-linear, how to categorize the systems. So under the system, now we learn what are the types of systems. So I'll just quickly summarize. Sir has already taught this, so I'll just briefly go through classification. You are following, right? If you have any doubts, you can stop me and ask, or you can mention in the chat box. If you are muted, if you cannot talk, if you are in the library, you can mention in the chat box. I'll respond. So till now, any doubts? Any one of you? No. Okay. So classification of systems. So the first one is linear and non-linear systems. Okay. So in our day-to-day life, most of the systems that we are seeing are non-linear. So anything that is not linear is non-linear. So there is a definition for linear system. And if that does not, obey those rules or those principles, then it is non-linear system. So what are those principles? Those are superposition theorem. So any system that is linear should obey superposition. Okay. So consider a system. Okay. I have one system and I am applying an input and I am getting some output. Say the input is u of t, okay, and the output is y of t. So for u of t, I am getting y of t. So now, what does superposition theorem says? So this is function f, right? Say the relation is some function f. Okay. So for u of t, I am getting y of t. Similarly, if I am applying u1 of t, say I am getting y1 of t. And similarly, if I am applying u2 of t, I am getting y2 of t. So this is the output that I am getting for the corresponding input. So now I'll superimpose u1 as well as u2. So now I consider the same system, say function f, and then now I will change the input. I'll give some k1 into u1 of t plus k2 into u2 of t. And if I get the output as k1 into y1 of t plus k2 into y2 of t, then this system is considered to be linear. Okay, else it is non-linear. So let me quickly take one example just to be clear. Say I have one function y is equals to 2x. Okay, so now I'm considering an input x1 and my output, corresponding output is y1 is equals to 2x1. Now I'll take another input x2, and for that the output y2 is 2 times x2. Now I'll change the input to k1 x1 plus k2 into x2. So for this input, what is my output? My output is 2 into k1 x1 plus k2 into x2, because it is 2 times input, right? Y is 2 times input. So 2 times input is k1 x1 plus k2 x2. So now if I simplify this, I can write this as k1 into 2x1 plus k2 into 2x2. So now once I do this, I can rewrite this as k1 into y1 plus k2 into y2. So is this system linear or non-linear? Anyone? Linear, yes. So the system is linear. So this is a linear system. Similarly, if it doesn't obey the superposition theorem, then it is non-linear. So as I said, there is a proper method to check whether the system is linear or not. If it is not linear, then we call it non-linear. But there is no such theorem that a system has to follow to be non-linear. So linear are a specific system. Anything that is not linear is non-linear system. So this is one set of system that we call linear and non-linear system. Now there is something called causal and non-causal system, and then static and dynamic system. So let us consider second one is static and dynamic systems. So what are static and what are dynamic? So static are memoryless, and then dynamic will have memory, because it doesn't have or store anything. Okay. Here I can consider example as resistor. Here I can consider the example of capacitor or inductor. Okay. So coming to resistor. So as I have mentioned, first one we are considering is resistor. So I'll consider one resistor, and resistor is R, current is I, voltage is V. Say V of t, I of t at that instant. So V of t is equals to I of t into R. So it doesn't have any memory because the instantaneous voltage will depend on the instantaneous current. Say I have considered a resistance uh, today, and then I'm considering a resistance tomorrow. I apply certain voltage, it remains the same. It doesn't have any memory, or it doesn't store any memory. Okay. So now let us move to the dynamic element and see what does memory mean. So now if I consider a resistance, sorry, a inductance or a capacitance. So let us consider inductance. So I'll consider an inductance. So I'll apply similar voltage VL of t. Inductance is L, current is IL of t. So you know the relation very well. V of t is L into DIL of t by dt. So now I can consider the inductance current IL of t is nothing but 1 by L into 0 to t V of t dt. So the current that is flowing in the inductor at time instant t also depends upon the voltage that has been applied from the very beginning, which means I have connected a certain voltage 2 volt for 2 seconds, and at the instant of second to 2 seconds I'll apply voltage of 3 volt. Then after 1 second, say at t equal to 3 second, what is the current? If I calculate it as IL1 of t And in the other case, initially I'll apply 1 volt, then I'll apply 3 volts. Both the currents will be different because the inductor current also depends upon the voltages that has been applied before that instant as well. So it has a memory, and that memory is governing what is the value at the current instant. Whereas in the case of resistor, it doesn't matter what voltage has been applied before that instant. It will be only dependent upon the current at that instant and vice versa. So voltage and current are dependent on the instantaneous values, whereas in the case of inductor, similarly for capacitor, the inductor and the current and voltages depend upon the past values as well, as if it has a memory. So these are called memory elements, and resistor is a memoryless element, and that's why these are this is static and these are dynamic. Anything that has dependence on the past is has memory, and they are dynamic elements. So, any doubts till this point? So there we have till now we have discussed two types of system. One are linear and non-linear, static and dynamic. And now we'll discuss about time variant as well as time invariant system. Any doubts till this point? No, sir. Okay. Time variant and time invariant. So as the name suggests,
Sir, can you explain this
which one?
linear and non-linear system?
Yes, yes. So linear systems are defined as those systems which follow superposition theorem. So if they follow the superposition theorem, then they are linear. So I have considered one system. Input to output relation is say function f. They're related by function f. And for say input I am defining by u of t, output I am defining by y of t. So for u1 of t input, I am getting y1 of t output. For u2 of t input, I am getting y2 of t output. So this is given. Now, if I apply a combination of these two input, which is k1 into u1t plus k2 into u2 of t, and if my output is k1 into y1 of t plus k2 into y2 of t, which means this is following the superposition theorem. So any system that follows superposition theorem is linear. If it fails to follow the superposition theorem, then it is non-linear. So I have considered one simple example, y equals to 2x. So my function is y output y is function of x, which is 2x. So y equals to f of x is equals to 2x. So if my input is x1, my output y1 is 2x1. If my input is x2, my output y2 is 2x2. Now my input is k1 x1 plus k2 x2. So if my input is this, my output will be 2 times of input, which is 2 of k1 x1 plus k2 x2. Now I can rewrite this as k1 into 2x1 plus k2 into 2x2. But 2x1 and 2x2 are y1 and y2. So I can rewrite this as k1 y1 plus k2 y2. So for an input of k1 x1 plus k2 x2, I am getting an output of k1 y1 plus k2 y2. So that's why it is following the superposition theorem, and that's why it is linear. But if it fails to do so, then it is non-linear. We'll be taking few more examples. I have few problems. There you will see why a system is linear or why it is non-linear. Is that clear?
Yes, sir.
Okay. So now coming to time variant and time invariant system. So any system that has parameters which are a function of time, then they are time variant. Any system that has parameters which are not dependent on time, they are time invariant. So time variant and time invariant, right? So how to check time invariant system? Time invariant, which means the output is not dependent upon at what time you are applying. Like say my input is u of t and my output is y of t. If I have delayed the input t minus tau, my output will be also t minus tau. Which means say I have a resistor. Okay, I have applied a certain voltage 5 volts today, and then I'll apply 5 volts tomorrow. The response or the current that it is drawing will not vary. It will remains the same irrespective of at what time I am applying the voltage. If the voltage is same, the current will be the same for a given resistor. Now coming to time varying. there will be some parameter that will be varying. So I can consider mass of a flight, say, or an aeroplane. So the mass of an aeroplane will change from the takeoff to again landing time because the fuel will be consumed. So the weight will change. So now if I consider at any instant, say the flight is just taking off, the mass will be different. In between during the journey, the mass will be different because half of the fuel will be consumed. Once it lands, the mass will be different. So now the same flight, depending upon at what time instant I'm considering, the mass is varying. So here the mass is a function of time and it is varying with time. So that's why it is time varying system, because in this case, the fuel is being consumed. So any parameter that are dependent of time, then it is time varying system. If none of them are dependent on time, then it is time invariant system. Depending on the input is different. Output is dependent on input, but any parameter in the system should not be dependent on time. So that is the difference. So is this clear till this point? So now the last classification is causal and non-causal system. Okay, so causal system means it depends upon the present input as well as the past input, not on the future. So causal system means output is dependent on the present and past input. So the best example is the inductor that we have considered. So if you see, the inductor current is dependent on the present input as well as the past input and not on the future. One more thing, so the Zoom that I am currently using doesn't have pro version. So at every 40 minutes, the meeting will end. Once the meeting will end, we'll have to join back. So within a minute, the meeting will end. So using the same link, please try to join back. And then again, next 40 minutes will continue and again we'll join. So it will end in a minute. Once the meeting ends, let us join back using the same link and then we will continue the discussion from where it has stopped. Is that clear? I think it will end within few seconds. Once it ends, please join back. Then we'll continue the session.
So how much time the one link will operate?
Which link? 40 minutes. So first 40
40
minutes,
minutes. Okay.
it will end. Again, we'll have to join back. The link will be active.
Okay.
Only using the same link, I have to join back. So, okay. So someone was asking, can you give any uh, example of time varying system? So I have a system. Say flight only we can take. Say the mass of the flight, mass m. Is a function. Say I can say some constant capital M minus 10t. So the mass is varying with respect to time and it's a varying function. So here the system is flight, but the mass of the flight is time varying. So please don't get confused with that. We are talking about the mass of the flight, which is time varying system. So the response of the flight is dependent on the mass. So it also is a function of time. Whereas in the case of resistance, the resistor value is independent of time. So the resistor value will remain the same. So the output of the resistor depends upon the input and not on any parameter that is a function of time. Whereas in the case of flight, say if I have to calculate the weight of the flight or if I have to calculate the acceleration of the flight based on the force. So now say force is given as F. and I have to calculate the acceleration. So usually if the acceleration is dependent upon the force, then it is time invariant. But if it has a parameter like mass, which is a function of time, now the acceleration also depends upon the time. For a same given amount of force, acceleration might be different at different time instant because the mass is different. So now this condition is called time varying condition, and this system is time varying system. Whereas in the case of resistor, if I'm applying 10 volts at this time instant, current is fixed. The same current will be generated even if I apply 10 volts after certain time because it is time invariant. It is not a function of time. So coming to non-causal system. So anything that is not causal is non-causal, which means it can depend on the future instant as well. So non-causal. Non-causal system. So output may be dependent on the future. Output may be dependent, not maybe, output is dependent on the future, not maybe, output is dependent on the future. Very simple example if I take say y of t is equals to 2 into 2x of 2t plus 3. So instead of x, I'll use u, 2 u of 2t plus 3. So if I'm applying say at t equals to 1 second, then u of t equals to 2 seconds plus 3. Because if I am calculating the output at 1 second, it depends upon the input at the 2 seconds. So it is dependent on the input which is in the future. So the current exact output is dependent on the future, and this system is non-causal. Whereas if I have a system y of t, which is u of t plus u of t minus 1, then it is dependent on the present as well as the past. So this is causal. So this is causal and this is non-causal. Similarly, sir has given one example, which is the guided missile. Why? Because say I have launched a missile, I have set a target on say one car, and car is moving. So the current direction of the missile is also dependent upon where the car will be, because the missile will not reach the current position of the car, right? The missile should reach the future position of the car. So the missile will hit the car in 3 seconds. So the missile should reach that position where car will reach in 3 seconds. So it is dependent on the future of the car, and accordingly it should move. So guided missile will have to calculate ahead and then reach the future location, and it should move to that position. So that's why it is also non-causal system. So is this clear until this point? Different classification of systems that we have discussed. Clear, sir. Okay. If you have any doubts, you can stop at this point. Now let us solve few problems. I have considered different set of problems. So y of t is 2 times x of t, y of t is 4x of t minus 5, y of t is x of t minus 4 of x of t minus 1, y of t is sin x, y of t is x square t plus 2x of t, y of t is x of t plus 2. So each of these, you let me know whether it is linear, whether it is causal, whether it is time variant, or whether it is time invariant. So another thing I would like to add for the time invariant. Yeah. So this is there. If input is y of t and output is if input is u of t and output is y of t, if I give u of t minus tau, I should get y of t minus tau. Yeah. So keeping that in mind, can anyone let me know what is the first system? Y of t is 2 into x of t, whether it is linear, causal, and
It is
time
a
variant or
causal,
time invariant.
causal and non-linear.
Non-linear or linear?
Oh yes, linear.
Linear and causal. Okay. Someone has
Yes.
asked, what is causal system? Can I repeat? So causal system is that system where the output is dependent on the present and past input. It is not dependent on the future input. So I have considered current in an inductor. So the current in an inductor is dependent on the voltage at this instant as well as the past. So it is causal system. Suppose if there is something that is dependent on the future, say the current output is dependent on the future input, then it is non-causal system. Like a guided missile. Say I have launched one guided missile that is aimed at a moving car. At t equals to 0, the missile is launched. So now the movement of the missile at this instant will be decided on the car movement and its future location, right? Because the missile should reach that location that car is going to reach in few seconds or few minutes. So the current output or the current direction of the missile is dependent on the future position of the car. So it is non-causal. And also sir has considered another example is when we are preparing for an exam, we will be preparing keeping in mind what questions might come in tomorrow's exam. So we are considering that this question might come tomorrow, which has not yet happened, and based on that we are preparing now. So our preparation, which is the output, is dependent on some input that might happen tomorrow. So we are preparing keeping in mind what can happen tomorrow. So we are dependent on something that is ahead of time. So the our preparation is non-causal system. Whereas say we are preparing only based on the past, previous solved question papers and nothing ahead, then it is causal system. Is that clear? Whoever has asked. Anushri? Okay. Questions. So now moving to questions. So y of t equals to 2 into x of t. Can anyone tell me whether it is linear, causal, or time variant or time invariant?
Sir, first one linear, time
Okay.
invariant, the cost.
Causal. Okay. Very good. Who is this? Palani
Palani
Kumar.
Kumar.
Yeah, nice. So the first system is linear because we have just discussed before y equal to 2x is linear, and it is causal because it is not dependent on the future input. It is dependent on t. So at that exact instant and not even on the past. So it is causal, and it is not also having any parameters that are time dependent. So if my input is x of t, output is y of t. If my input is x of t minus tau, output is also y of t minus tau. So that's why it is time invariant. So this system is linear, causal, and time invariant. Okay. So now what about B? Anyone?
Second one also the same, linear, causal, time invariant.
Okay. Uh, everyone agree? Everyone agree? Hello. Whether this system is linear or non-linear. Okay, just think about it, whether it is linear or
Linear, sir.
non-linear. Linear. Okay.
Linear.
Okay. So this is one famous interview question. Also, it is very tricky. It is actually non-linear system. I'll prove by. Uh, we have said that it should follow superposition theorem, And if it fails to follow superposition theorem or obey superposition theorem, it is non-linear. So looking at the equation, it will look like y equal to mx plus c. And if you draw the curve, it is linear curve. And we think that it is linear system. But linear system does not mean the graph is linear. Linear system means it should obey superposition theorem. So let me just consider this. I'll rewrite it as y equal to 4x minus 5 for the time being. Okay. So if my input is x1, my output y1 is 4 into x1 minus 5. If my input is x2, my output is y2 is 4 of x2 minus 5. Now if my input is k1 into x1 plus k2 into x2, then my output is what? For this input, I will get 4 of k1 x1 plus k2 x2 minus 5, right? 4 into input minus 5. So this I can write it as 4 k1 x1 minus plus 4 k2 x2 minus 5, right? So is this equal to 4 y1? Sorry, y1. So is this equal to k1 into y1 plus k2 into y2? Is this expression equal to this? Or let us calculate k1 into y1 plus k2 into y2. So k1 y1 plus k2 y2 is 4 k1 x1 plus 4 k2 x2 minus 5 k1 minus 5 k2, right? So is my output equal to k1 y1 plus k2 y2? Hello?
No,
No, right? So
no.
it is not equal to this, and that's why it is not linear. So it doesn't follow or obey superposition theorem. So that's why this system is non-linear. Although from the equation, it will look like it is linear, but it is not linear and it is tricky. And this is causal, as everyone said, it is dependent on the past input, and it is also time invariant. Okay, so just to write y equals to mx and y equals to mx plus c. So y equals to mx is linear and y equal to mx plus c is non-linear because it will not obey superposition theorem. So don't get confused based on the graph shape. So it is not linear. And now coming to the third one, y equal to x of t minus 4 of x of t minus 1. Anyone?
Non-linear for
X of t minus 4 of x t minus 1. Okay, so is this linear, non-linear, causal?
non-linear,
Okay,
time variant,
okay,
and non-causal.
okay. What about others? What do
Sorry,
you
causal
think?
systems.
Causal system. And is it linear
Causal.
or time
Non-linear.
non-linear? Why are you saying so?
This is Palani Kumar.
No, no. Why are you saying that it is?
This is because it depends on present and past inputs here. Y x of t minus 4 x of t
T
minus
minus
1.
yes.
So this is linear system only, sir. Sorry.
Linear only, right? Yeah. You have to see
Linear. Yeah.
every time when you are given a system, right? So without making any mistake, you can blindly follow superposition theorem. You check
Okay,
u1
okay.
of t, y1 of t, u2 of t, y2 of t, k1 into u1 of t plus k2 into u of t, output is this or not. If it is following linear, if it is not, non-linear. And then coming to causal system, if the input is dependent on the present, output is dependent on the present input and past, then it is causal. Time
sir.
varying, you see if input is u of tau, u of t, output is y of t. If input is u of t minus tau, output should be y of t minus tau. So you can replace t with t minus tau and check whether it is still the same or not. And if it is, then it is time invariant. So this system is also linear, causal, and time invariant. Right? Everyone agree?
Yes, sir.
Time invariant. Okay. So now y of x, y of t is equals to sine of x of t. So y is nothing but sine x. So here x is a function of time. So basically y is sine x. So what system is this? D. Y of t is sine of x of t. So first of all, is it linear or non-linear?
I
Whether
have one
it
doubt, sir.
yes, yes.
It is a C example. This is whether it is a whether it is a time invariant.
Yes, it is time invariant.
This is x of t and this is x of t minus 1.
Yes, yes,
Present
yes.
and past.
Yes, I'll just show. So basically, time invariant comes from this condition. Say if my input says x of t and say my output is y of t. And if my input is x of t minus tau, output should be y of t minus tau, right? Say if my input is x of t minus tau, then my output y is nothing but x of t should be replaced by t minus tau, right? Minus 4 of x of t minus tau minus 1. So this is nothing but y of t minus tau, right? I'll give you one example. Say y is equals to x of 2t. Y of t is equals to x of 2t, right? So now if my input is say x of t minus tau, now t I am replacing with t minus tau. So my output is what? X of 2t minus 2 tau, right? But this is not equals to y of t minus tau because y of t minus tau is nothing but x of 2t minus tau. So you delay the input. So you delay the input. Say my input is t. Now I am replacing t with t minus tau, and then see my output is same or different. If the output is different, if it is not y of t minus tau, then it is time variant. Similarly, here I have considered x of 2t. So if I am replacing t with t minus tau, my output is x of 2t minus 2 tau. So my output is delayed more. So depending upon the input, the output is changing. So it is a function of time, and that's why it is time varying. Is that clear?
Yes, yes, sir.
Okay. And sin x, can anyone tell me about sin x?
That is linear.
Okay. Is it linear?
Then depend on time varying and invariant. I have some doubts, sir. If we are applying t equal to 0, sine
Uh-huh.
0 is 0. If I am applying sine 90 degree, it moves to plus 1. We are applying again 180 degree, it comes to 0. If we are applying 3 by no, sorry, 2 by 2, that is to 70 degree. That is in
Yes.
positive, it goes to negative side. That's
Okay.
on future or past. How can we consider that time?
Okay, okay. I
That's
think you have
on.
some doubt. So yeah, I'll explain part by part easily. So first,
Okay.
is this linear or is this non-linear?
Linear.
How are you saying it is linear?
Mm, y1 of t depends upon sine of x1 of t.
Okay,
y2 of t sine of x2 of t.
okay,
k1 y1 of t equal to sine of k1 sine x1 of t. y2 of t k2 into sine x2 of t.
okay. So you're saying it
So
follows superposition.
yeah.
Okay, okay. Just let us write it and check. So if I have x1,
Okay.
my output is sine of x1. Agree?
Yes. Yes,
If
sir,
it
yes,
is
sir.
x2, it is sine of x2.
Okay.
Say this is my y1, this is my y2. So if my input is k1 x1 plus k2 x2, what is my output? Sine of k1 x1 plus
Okay.
k2 x2, right?
Yeah.
So is this equal to k1 into sine x1 plus k2 into sine x2?
No.
No, right? So
No,
this is
non-linear.
non-linear, yeah. So this is for the linearity, whether whether it is linear or non-linear, we are checking. Now coming to causal. Causal means output is dependent on the present input or past input. So if you consider y of t, it should be dependent on x of t or x of t minus 1, x of t minus 2, x of t minus 3 past. So it should not depend on x of 2t or x of 3t, x of t plus 4, x of t plus 5. So is it dependent on present and past, or is it also dependent on the future?
Present past only.
Past only. So it is causal, right?
Yeah.
Yeah. Coming to time varying, one point that you have said is correct because y is changing. But time varying does not mean that value is constant. Time varying in the sense, I'll tell you, because see, any function can vary with time, right? So if my input is varying, output is also varying because output is a function of input. But time varying doesn't mean that. Time varying means if the moment at which the input is applied also decides my output, then it is time varying. Time varying in the sense, for a given input, output will change with respect to at what time you have applied the input. So that is time varying, which means, say if I have applied my input x of t and my output is y of t, if I have delayed my input by x of t minus tau, output also should be delayed by t minus tau. But if it is not delayed by t minus tau, it means the output is dependent on at what time you are applying. So in this case, if my input is x of t, which means my output is sine of x of t, which is also equal to y of t. If I replace t by t minus tau, then here also I'll replace t by t minus tau. So this I can represent as y of t minus tau. So if I'm delaying my input, my output is also delayed in the same way, which means if I'm applying fixed input at this time, whatever output I am getting, I'll also get in the future. Like if I'm applying the same input, it doesn't matter whether I'm applying today or whether I'm applying tomorrow, output will be same for the given input. So that's why it is time invariant. Time invariant. Is this clear? Yes, sir. Okay. So
Yes,
now
sir,
coming
yes, sir.
to E, x square of t plus 2x of t. So x square of t plus 2x of t, E. Anyone? Linear, non-linear, causal?
Non-linear,
Okay,
non-linear
non-linear.
and causal.
Okay, others agree?
No, sir, non-linear,
Very good.
non-causal,
Why it is
non-causal
non-causal or
and
is it causal?
x square of t.
Causal.
Okay,
X square.
how are we checking whether it is causal or not? It is dependent on the
Present
present
time,
and past input, right?
present time is present, x of t only.
Yes.
X square of t.
X square of t. So it is x of t into x of t. But at
So
the
this depends upon future only. That
no, it is
output
not
depends
future.
upon
It is
future.
not. It is not x of 2t. It is x square of t, which is x of t into x of t.
X of t. Okay, so
Causal only, right? Yeah, it is
causal
causal.
only.
And time variant or time invariant?
T minus 2.
Time invariant.
Time invariant. Very good.
Time invariant.
Yes. So I hope others are also following. I am only hearing from few people. So if others have any doubt, please stop me. I'll explain it again. Till now, is this clear, everyone?
Hi, sir. I'm
Sorry.
sir. I'm
Yes,
audible.
Yes, yes. Vijay Kumar.
yes, sir.
Uh,
Clear,
I,
sir.
sir, I'm audible, sir.
Yeah, yeah. Is this Prashant speaking?
Yeah, sir.
Yeah.
Sir, from adding to your point, sir. Suppose we have to say linear if the system is linear or not. If
Okay.
suppose if we have a equation y equal to mx, so if the equation passes through the origin, we can say it is linear. So
Yes.
if y equal to mx plus c, if it won't pass through the origin. So
Yes. Very good.
we can say it is not a linear system. Suppose
Ye-
imagine that it will be easy to answer quickly.
Yes, yes. Very
Other
good.
than that, mm, the casual and non-casual can
Sorry, sorry.
it's difficult to understand that casual and non-casual.
Okay, okay. I'll re-explain that again. Any other doubt? Any other doubt, Prashant?
Okay, sir, everything fine.
Okay, okay, no doubt. Okay. So Prashant has pointed out one very good point. So what he said is any straight line passing through origin is linear because y equal to mx is linear, y equal to mx plus c is not linear. So I can say that any straight line, passing through origin is linear. Okay. So any straight line that is passing through origin is linear. So coming to his doubt, causal, non-causal, I will clarify it through this last problem, which is y of t equal to x of t plus 2. So here I'll specify and then I'll try to clarify your doubt whether it is causal or not. So y of t is x of t plus 2. So can you tell me whether it is linear, non-linear, time variant, time invariant, or causal, non-causal? Anyone? Okay, someone has mentioned in the chat.
This is
It is
non-causal.
linear. Okay, very good. It is linear. Someone mentioned in the chat. Time variant or time
And
invariant?
Invariant.
Invariant. Very good. So, Prashant, coming to your point, whenever we say causal, so y of t should be dependent on the present input x of t or past input like x of t by 2, x of t by 3, x of t minus 1, x of t minus 2, etc. If I'm saying non-causal, it is dependent on the future input, which means for calculating y of t may be a function of x of 2t. So it is future. At t equals to 1, I'm depending upon input at t equals to 2 seconds, future. X of 2t plus 3, any future. Or x of t plus 1, also future. X of t plus 2 in this question is future. X of 10t minus 1 may be future. So any possibility of future means non-causal because 10t minus 1, if t equals to 0, it is dependent on the past. But for t equals to 1, it is dependent on the future. So it is non-causal. So any system that is not linear is non-linear. Any system that is not causal is non-causal. Any system that is not time variant is time invariant. So we have definitions to check linearity, causality, and whether it is time invariant or not. If they do not obey this, then it is non-linear, non-causal, and time variant respectively. So is that clear, Prashant?
Yeah, sir. Clear, sir.
Okay, okay. Any other queries? Okay. If you do not have any queries, then what is control system? So till now we have discussed about system, which means any system, air conditioner, mobile phone, human body, human mind, hands, car, aeroplane, anything is system. What is control system means? It's an overall system along with the controller. So there will be controller, there will be feedback, and then there is system. So this is just a diagram I'm drawing. The details of the controller will be discussed in the upcoming weeks. So we have controller, we have system. So we have controller, and then we have system here, whatever system, any system it can be. And then this is the output. So controller is giving the input, and who is giving the input to the controller? The user is giving. Say this is the desired input. So like the desired output, whatever we are needing, the desired output, whatever we want, that we are giving. And the output, so this is the output. So the controller needs to know the feedback. I'll take an example and I'll explain you why it needs feedback. Say we are considering air conditioner, which is a day-to-day example. So you might have seen split AC. So I want the temperature of the AC to be 25 degrees, say, and it is hot summer day, and the outside temperature is 35 degrees. So now I am telling the AC to maintain the room temperature at 25 degrees. So now the compressor will be on, and then it will try to reduce the temperature from say 35 degrees to 34, 33, 28, 27, 25. And now the compressor should stop at 25 degrees. So how does it know that the room temperature is at 25? So it needs to have a sensor. So the sensor will sense the temperature and tell the compressor that now you have to stop cooling down the room. So feedback is needed because my desired input, whatever, instead of I would say desired output, I'll say desired reference so that there will not be any confusion, because this is the input that we are giving, and if I call it as output, it will be confusing. So desired reference. Okay. So I am giving a reference, 25 degrees is the desired temperature that I need. So now what is the controller? The controller is the compressor, whether it will be turned on. If it is on, temperature will come down. If it is off, temperature will go up. So once the desired temperature is hit, it will turn off, and again the temperature will rise slowly. Again it will turn on, and it will try to maintain 25 degrees centigrade. So this is the controller, and my what is the output? My room temperature is the output. And there can be any disturbance. Say I have opened one window, then what happens? The temperature will increase fast. So now the way the AC should be turned on will change because that is some disturbance. Say 20 people have entered the room. So now the AC should be turned on for longer time because the temperature will increase if the number of people increases. If there is no one, then there will be a certain way of action. If there are people, there will be certain way of action. But my sensor is giving the feedback to the controller, so it will decide how long it has to be turned on or off. So basically here the system is the room, and the output is the room temperature. So controller is the air conditioner or compressor, whatever. It is trying to control the room temperature by turning on or off and by taking feedback using the sensor. So the sensor will let us know the temperature. And again here there are many disturbances, like say I have opened the door for 5 seconds and then temperature will go up. Now the controller should act accordingly. The
Here,
number of persons are entered, then again it will act differently. So this is the overall control system. Similarly, if I consider car, so car will also have a control system. Let's say we are the controller in the car. So the desired reference is what? We have to go in the straight line. So our eyes are the feedback. Say if we are going towards the right side, then we'll tilt the steering to the left side so that we'll come in the straight line. So now we are the controller and we are giving feedback through the steering. and the system is the car, output is we have to go in the straight line. So this is one type of control system. Similarly, if we are going in an aeroplane and say we have to go at 8,000 feet, if my like height is more, then I should come down. If my height is less, I should go up. So there will be a sensor which will give the feedback, and accordingly the pilot should either go up or down. So pilot is the controller who is controlling the height, and he is getting feedback from whatever sensors they are there in the aeroplane, and then he's trying to system is the aeroplane. He's trying to control the system, and overall desired output is the altitude at which you are flying. So this is the overall system. Is this clear, everyone? What is an overall control
Yes.
system? So in this course,
Yes.
now we are going to discuss or learn about how to design a controller, what is a closed loop system, how to design this, how to run a closed loop, how to check the stability of the system, how to model a system, what is importance of modeling in time domain, S domain, as well as frequency domain. Multiple domains we'll try to understand, and everywhere we'll try to have this feedback controller system, and this overall system is control system. Is that clear?
Yes, sir.
Okay. So again, there is less than a minute. So this meeting might end, and then we'll again join back, and then we'll continue our last 40 minutes so that our 2-hour session will be completed. But before that, I'll discuss few examples, one from the electrical system, one from the mechanical system, and then we'll correlate both the systems by modeling the circuit, and then we'll move to another model, which is predator-prey model. So once this meeting ends, kindly join back. We'll discuss about 3 important models. One is series RLC model, another is the motor model, not motor, spring mass damper, and another is the predator-prey model. So these 3 models that Sarah has discussed, we'll revise and then correlate between these 3 models. Is that clear?
Yes,
We'll
sir.
take, okay, yeah. Once this meeting ends, kindly join back, then we'll start solving these problems. Can you see my screen?
Yes, sir.
Okay, so we'll consider one electrical system, which is standard series RLC that Sir has discussed. So we'll try to correlate electrical system with the spring mass damper. So let us consider one series RLC circuit. R, L, and then C. Say capacitance is the output, and input I have excited with a certain voltage. And these are R, this is L, this is C, this is my output, which is Vc of t. Input is V in of t. And say current I am measuring IL of t. So if we apply Kirchhoff voltage law, can anyone tell me what will be the equation? V in of t is? V in of t.
I into R plus
IL of t into R
plus L di by dt
plus L di by dt
plus 1 by C integration of I into dt.
plus Vc of t, right? Which is 1 by C integral Ic of t dt, right? Agree? Is this okay for everyone?
Yes, sir.
Okay. So now, okay, someone has mentioned. Yes, sir. So so now let me rewrite this expression. So we'll have V of t is equal to L into dIL by dt plus R into IL of t plus 1 by C into integral I dt. You know that what is current in terms of charge, anyone? I equal to dq by dt, right? Charge, current in terms of charge. Yes. So now if I calculate integral of I dt, integral of I into dt, then it will be q, right? And so basically integral IL dt is q. So IL of t now will be derivative of q. So I can write it as q dot, which is dq by dt. So now similarly I can write dIL of t by dt is nothing but q double dot, which is second derivative of the charge. So these are the notation, standard notations that we follow. I am just rewriting it. So is this clear? I is nothing but rate of charge. So I is dq by dt. So now I'm converting everything in terms of q. So this will be q, this is q dot, this is q double dot. So now if I rewrite the original equation, I will get something like this. V in, if I remove t, because just for simplicity, I'll get L into q double dot plus R into q dot plus q by c is the final overall equation. Everyone agree? Is this okay? Yes.
Yes, sir.
Yeah. So this is one set of example where we have applied Kirchhoff's voltage law. But similar thing sir has done for Kirchhoff's current law, where all of these are parallel and input is a current. So similarly, if you apply KCL there, you will get a different set of equation, and sir wanted to compare this equation with that equation. But because that sir has discussed, I am just revising. I am not considering each and every example that sir has considered, but I'm trying to cover each and every topic. So here we have considered one electrical system, and then we got a second order dynamical equation. So this is a second order system. So now, if you do not have any doubts, let us move to a mechanical system. So here I'll consider a spring mass system. Okay. So let us have a spring mass system, and so this is the surface. Okay. So here we have mass m. So it has one spring connected here with a spring coefficient k, and it also has a damper with b, damping coefficient b, and we are applying a force F on the right side of this. So can anyone tell me what will be the equation of this mechanical system? Okay, someone is joining. And then say the displacement is x.
Sir, yeah, f of t equal to
Yeah, f of t is equals to
m into d square x by dt square
m into d square x by dt square, which is acceleration,
minus
minus
b into x dx by dt
dx by dt
minus kx.
minus kx equal to 0. Only it is not minus, it is plus, because all are trying to opposite. So the amount of force that is pulling in this direction is also kx, right? So why minus is coming here? The overall force defines how much is the x, right?
displacement is in the rightward direction, that is x. So damper element and spring element will try to oppose the.
Like minus kx. Basically, what I can say is the net force. I can write like this, right? So they are trying to oppose, right? So the force F, net force is F minus kx minus b into dx by dt is my net force, which is my m into acceleration, which is m into d square x by dt square. Agree? Because they are trying to oppose. So the net force
Yes, sir.
on the right
Yes.
side is this force minus the damping force minus the spring force, whatever it is pulling back, is the net acceleration, like it's the net mass into acceleration. So now if we calculate, okay, now that you have pointed this, I'll also solve one problem where sir has discussed how to solve spring mass problem. So there are steps and guidelines that sir has told, so that we'll also solve one problem so that we'll get a better clarity. So now this I can write it as F is equals to m into x double dot plus b into x dot plus kx. Agree everyone? This is the final equation that we are getting.
Yes.
M into x double dot plus b into x dot plus k into x.
Yes, sir.
Okay. So here we have considered previously one electrical system where we have RLC and then one input voltage. Now we have considered one mechanical system. We have spring mass system F and then Bx and then K. So if we consider some other rotational, so this is translation motion, right? If we consider rotational motion, with torque and then angular displacement, we'll consider similar, what do you say, expression. We'll have torque T is nothing but J theta double dot plus D into theta dot plus K into theta. So this is also some second order expression in terms of torque. So if we apply torque T and it has inertia J and the momentum is theta, so the amount of torque that we have applied is relevant to or related to the angular displacement theta in this equation. So there are different types of systems, maybe second order, first order, but here we have considered three such second order systems. So now we can correlate one system with another, which is what I have considered one problem here. So this is our second problem. So consider one mass spring mass damper system with spring constant K, damping coefficient B, and mass M subjected to an external force F. Derive the differential equation governing the system and determine the analogous parameters corresponding to the previous question using force voltage analogy. What is FV analogy? So force is related to this mass spring damper system. Voltage is related to the series RLC system. So basically what we are trying to do is, here we are asking to compare which parameter is corresponding to what. So this is one equation that we got, and this is another equation that we got. So now if you see, both are in the same way, which are in the second order. So basically now we are comparing two systems. Okay. First system is mass damper, spring mass damper, because there are three. One is spring mass damper. The other one is RLC circuit. So if you see, if you compare each expression, what is force F here? Say here it is force F.
Voltage.
Voltage, right? Input voltage, V. So force in this is related to input voltage there. And mass?
Inductance L.
Inductance L. Very good. And then B?
Friction, that is
Friction is
resistance.
resistance. Very good. And then
Spring,
K, spring constant,
that is nothing but 1 by C,
1
reciprocal
by
of
C,
capacitor.
reciprocal of capacitor. And what is X, displacement?
Displacement is nothing but charge.
Charge. Very good. So this is how we can correlate spring mass damper with RLC circuit. In the same way, I can add this rotational motion, this equation also. I can compare torque. So force will be nothing but torque, and then mass is nothing but moment of inertia. B is nothing but D, rotational damping constant, and K is K, and then X is theta. So in this way, we can compare different type of second order systems and then see how they are analytically related in two different systems. Here, one being spring mass damper and another being RLC circuit. So is this clear until this point? How we have considered two systems and then compared both of them.
Yes, sir.
So I'll solve one problem of the spring mass damper. Let me consider one problem because people have asked. So sir has mentioned certain steps. Okay, so we any spring mass damper. So this will be our problem 3. Solve the following spring mass damper. Write the dynamical equations. Okay, so I'll consider one question. What we have to do is write the dynamical equations, not basically solve. Consider the following spring mass damper. Consider the following spring mass damper and write the dynamical equations. So sir has mentioned a few guidelines. If we strictly follow them, it will become very easy for us to solve. So I'll consider the problem and then I'll let you know how to solve this. So here we have the ground. Okay, so here we have two masses. One mass here, another mass here. So this is called mass M1. This is mass M2. Here, say it has wheels. And then here the friction is say B1. And here the friction is say B2. Okay. Now there is a spring here, which is K1 here. And then here we have K2. And then say here there is another damper between these. Say this is K1. This is K12, because it is between 1 and 2. And say this is B12, which is between 1 and 2. And here we have a force F. Okay. So say we have such dynamical system, multiple masses, multiple friction coefficients, multiple springs and everything. We can make it into a simple circuit and then we can write the expression rather than looking from this view and then see how we can write the equation. Say the direction is x1 in this and x2 in this. So we can, if you look at this problem based on the force, how we have done this in this previous case, you can do in that way, which is F minus Kx minus this, but there are two such movements, right? X1 and X2. So we have to consider the effective displacement. So what we can do is we can follow few guidelines. First guideline is check how many displacements are there, meaning how many springs, or like we are considering two masses, right? So mass M1 is moving by X1, mass M2 is moving by X2. So how many displacements are there?
2.
2. Number of displacements is equals to 2. And then you have to identify the nodes, number of nodes, so that we can consider as a node in the electrical circuit. Basically, we'll convert this into our electrical kind of circuit and then convert that into equation. So here we have basically three nodes. One is the reference node, which is this wall, and then another one is this mass. This is one node, this mass is one node, and this is another node. So I can represent that mass by a single node. So we have two nodes plus one reference, which is this ground. So this is our reference. Okay. So once you identify the displacement and identify the nodes, so displacement 2 means I need two equations. Nodes 2 means in my electrical circuit, whatever I am drawing, I will have 2 points. So one is this x1 and then another is this x2. And then this is our reference. So this is our reference. Okay, so this reference, this point is x1, say this point is x2. So between x1 or this mass, what is connected? K1 is connected to the ground, right? So I'll connect K1 to the ground. And then it itself has one damper. So I'll also connect a damper. What is its damper? It is B1. And then the mass, of course. So mass is connected. So each of this will give equation. So we have mass connected. So basically we are trying to correlate and then get an expression, dynamical expression. Similarly, x2 has what? x2 has mass m2 connected to this reference, and then it has a force F, which means it is an input plus minus voltage. So how it is going to help? If you see, force is nothing but V, M is nothing but L, B is nothing but R, K is nothing but 1 by C, X is nothing but Q. So basically we are trying to convert everything into an electrical equivalent circuit. So once you do this, what is there between X1 and X2? B12 is there and K12 is there. So between X1 and X2, I have one spring and then one damper connected, which is B12 and K12. So now I'll write an equation 1 at x1 and equation 2 at x2. So if I write equation 1.
Sir, in node 2, there is one friction B2.
Oh, sorry. Yeah. Very good. Thanks for pointing this out. Yeah, thank you. I have missed it. So we have mass M2 as well as friction B2. So at this point, we have B2 and then we have M2 mass. So we are considering as if it's a RLC equivalent, but in terms of mass. So at equation 1, x1.
Sorry for interrupt you, sir. That notations for spring and damping is changed. Spring is K12 in upwards and damping.
Oh, yeah. Sorry. Yeah, thanks for correcting. So this is K12. Yeah, thanks for correcting. This is B12. So now we need to write the equation at x1 and equation at x2. So at x1, there is no effective force that is applied. So everything summation will become 0. Whereas on the x2, force will be equivalent to whatever the effective terms that we'll be getting. So at equation 1, we have B1 into x1 dot plus K1 into x1 plus M1 and M2. So this is M1 into x1 double dot. Now we'll consider the K12 B12 effective displacement, which is x1 minus x2. So K12 into x1 minus x2 plus B12 into x1 dot minus x2 dot is equals to 0. All with respect to x1. Now coming to equation 2. So now here we have force. So force will be equivalent to what all that is applied. So force F as if voltage. So force F is nothing but first we have M2, which is M2 into x2 double dot. Then we have B2 into x2 dot. Now it is with respect to node x2. So it will become x2 minus x1. So K12 into x2 minus x1 plus B12 into x2 dot minus x1 dot equals to 0. So this is our equation 1 and this is our equation 2. So two equations, two unknowns. So like if we want to solve, then that's how we solve it. Is this clear how we solve? So in each and every spring mass damper, first thing what we have to do is we have to find the number of displacements x1 and x2, and they will be usually they will be the nodes. So two nodes and one is reference. So everything we are writing with respect to reference. So once we identify the nodes and the reference in our electrical equivalent circuit, we have to write the nodes and the reference and then connect what all are there between these two nodes with respect to reference or within them. So once we write that at x1, there is no force. So each term corresponding to certain expression, summation of all those expressions will be 0. So this is corresponding to b1 x1 dot, this is corresponding to k1 x1, m1 x1 double dot, this is b12 into x1 dot minus x2, this is k12 into x1 minus x2. Similarly, for x2, there is force F. So force F corresponds to what all expressions that are being caused by this individual parameter. So one is m2 into x2 double dot, b2 into x2 dot. Now these are with respect to x2. So x2 minus x1 into k12, x2 minus x1 into b12. So if this is connected to node, then it will be x2 minus 0, which is x2 for these two terms. So this is how you write the expression. Same thing you can do for this expression also. Here we have one node and then one reference. So this node is corresponding to x, and then we have force F is equals to m into x double dot plus b into x dot plus k into x. So this also we can rewrite into one electrical equivalent. So we have a single node and then we'll have reference here. So this single node has three terms. One is the spring constant, one is the damper, another one is the mass. So this is K, this is B. And this is corresponding to X. And then also, of course, there is a force F, which is the voltage equivalent. So if it is single spring mass damper, it is like this. If there are multiple, then we'll have a little bit complicated, but once you draw the circuit, it becomes very easy. So is this clear until this point? Palani Kumar says clear. What about others?
Clear, sir.
Okay. So if there is no doubt, we'll move to some interesting model, which is predator-prey model. So the model is simple. We have a pond. Okay. So this is a pond. Assume this is a pond and we have water in this. Okay. And then it also has some vegetation like plant-based food, some grass, algae in the pond. Okay. And then we have small fish, which I'm marking with blue color. So small fish eats vegetation, and then our assumption is there is infinite algae, infinite vegetation, which means as long as the time is concerned, the fish will increase. So they will eat, they'll be healthy, and then they'll population will be increased. So these are the small fish, and then they eat only vegetation. So now we are considering another fish, which are bigger fish, which I'm considering using red color, not red, orange color. So these big fish eat the small fish. Okay. They don't eat vegetation. Okay. So the orange fish is the predator, blue fish is the prey. So we have blue fish, which is the small fish, which is also the prey. we are considering this as a variable x. And then the orange fish, which is the big fish, which is the predator, which relies on the prey, we are calling this as y. So what happens is, say the bigger fish is not there and there is infinite vegetation. Theoretically speaking, the small fish will keep on increasing ideally and it will grow exponentially. Similarly, if there are no small fish and then there are only big fish, orange fish, they have nothing, no food to eat, and then they'll decay exponentially. But once all the fishes are there, then there are some cross dynamics, because say if all the big fish have eaten most of the small fish, then there will be very less small fish. So some of the big fish will starve and some of the big fish will die. And say big fish has died, some of the big fish, then no one will eat the small fish. As there is infinite vegetation, small fish will grow. And now small fish is growing. Now big fish will start eating the increased number of small fish, and then they will also increase the population. And then this can continue in a loop. So there will be increment and decrement in the population, and then they can rotate. Here the assumption is vegetation is infinite. So the small fish will not die because of starvation. The small fish will die only because the big fish will eat them. So this is the only assumption that we are making. So in such case, there is this dynamic model, so that is called the predator prey model. So we have dx by dt, which is the rate of change at which the prey is changing, is alpha x minus beta xy, and then dy by dt is equals to gamma y minus delta xy, minus and plus. So basically what it means is, say x is prey, right? Say if y equals to 0. So I'll consider two conditions. First is y equals to 0 means there are no big fish. There are no big fish means dx by dt is equal to alpha x. So there is no bigger fish that is going to eat the small fish, which means x will increase exponentially. So they will increase exponentially. Similarly, if there are no small fish, say there are only big fish, they'll die of starvation because they will not have any food. So dy by dt will be minus gamma y, which means y will decay exponentially out of starvation. But if there are certain x and certain y, then they can increase or decrease depending upon time based on these expressions, as well as alpha, beta, gamma, and delta values. So they are called, so these equations have a name, they are called Lotka-Volterra equations. Lotka-Volterra equation. So this is called predator prey model. So now I have considered a MATLAB code of this. So till now there are no questions, right? You have understood what is predator prey model. So this is a system where we have small fish, big fish. Small fish will eat vegetation, big fish will eat small fish. And then depending upon the quantity, they can die or they can grow, and these are the equations. Although there are many other factors, say some human comes and then takes out small fish and big fish both and then eat, then the population will go down. But here we are very ideally speaking, and we have considered such equation. So this is the predator prey model. I hope you are able to see the screen. So here is a code. So I'll quickly explain. CLC meaning it will clean whatever is there in the command window. Clear means whatever is the workspace that will clean. Say a equals to 2, if I do, then a equal to 2 has come on the workspace. So now if I do clear, the workspace should disappear. So if I press clear, then workspace, whatever is there, that is disappear. CLC means this command will also will be cleared. Close all means if there are any plots that are open, they will close. So parameters, what are the parameters? So parameters, if I come back here, alpha, beta, gamma, and delta. So here are some parameters, 1.1, 1.5, and 0.075 are the parameters that I have considered. And dx by dt is the rate of change of x variable, right? So dt is some small number. If I consider exact dt, it should be very fine, right? It should be 0.00001. But for the sake of simulation, I have considered dt to be 0.01, and time I have considered from 0 to 100. Say 0 to 100 seconds I am considering, and incremental of dt is 0.01. So now I am saving my data in X. One is prey, Y is the predator. So the value of X, how much prey is left, how much predator is left, this X and Y I am saving in this X variable as well as Y variable. Now I have to give initial condition X of 1, which is 10 I have given, Y of 1, which is 5. Now I have running the for loop so that I'll calculate X of k plus 1 from this dx by dt. I know dx, which is alpha x minus beta xy into dt. Now my x will be x plus delta x. So that is what I have written, xk plus dt into this. Similarly, y of k plus 1 is yk plus this into this. And then it will run in loop, and then we'll see whether the this will increase or decrease. But I'll also like to add one thing. Say the system has reached steady state. What is steady state? Steady state in the sense, what is steady state? Steady state means population is constant. Means it is not changing. Population is constant. So if the population is constant and say nothing is changing, then my dx by dt, rate of change of population, is 0. Similarly, rate of change of this population is also 0. So now if you consider alpha x equal to beta xy, you will get y is nothing but alpha by beta. And from this equation, you will get x is nothing but gamma by delta. Right? Agree? At steady state. So let us see what alpha beta I have considered. Alpha I have considered 1. So in our problem, we have considered alpha to be 1 and beta to be 0.1, beta to be 0.1, and then gamma to be 1.5, gamma to be 1.5, and delta to be 0.075, delta to be 0.075. So y is what? My steady state y is 10, and then x is gamma by delta. So let us calculate 1.5 by 0.075. It is 20. So x is 10, sorry, x is 20 and y is 10. This is my steady state. So if I start with this, then it will not increase because the amount of small fish die is equivalent to amount of small fish that are born, and the amount of large fish that is dying, the amount of large fish is born. But for the time sake, I'm considering a different initial condition and I will run it. So let it plot. So this is the plot that you are going to see. So these are individual points at which the predator and prey model are increasing. If you see, they are going in some circular loop because at some point of time, the predator, what is predator? Population will increase, and sometimes predator population will decrease. Sometimes prey population will increase, sometimes prey population will decrease. So if we keep on increasing, we can see whether it is increasing or decreasing based on our dynamical equation. So it is happening in a certain kind of circular loop. So at some point of time, predator population will increase, and then they'll try to eat more prey, and then the food will go down, and then predator will die of starvation. So the predator will go down. So now prey is not being eaten by more predators. So prey will go up, and again predator will have more food. Again they will go. So in this way, it is happening in a loop. So now I can consider any initial condition. Say I can consider 1, 5. I'll see whether it will tend to 0 or what will happen. So now if I start with 1, 5, the way that it has increased is a little bit different from the previous case, because now if you see, either they're increasing gradually or becoming very less, because I have started with 1 fish, which is very less. Maybe if I start with 10 and 50, and then I can see how it will increase. So here again, the way that they are increasing is different because bigger fish are more, smaller fish are less. So depending upon what initial condition you consider, it will vary. But what if I consider the steady state? Say the steady state is 20 and 10, right? So if I start with 20 and 10, 20 this fish and 10 this fish, then what happens? Then it is steady state. So the increment is 0. So it is fixed. So the number of small fish growing is equal to number of small fish dying. The number of big fish growing is equal to number of big fish dying. But if I make any change, say if I consider 21 and if I consider 9, there can be some dynamics because it is not steady state. So now it is happening in certain different circular loop because it is not steady state. But say if I have considered more, little bit more here, say 25, and here say if I considered 5. So now I have considered some disturbance in the equilibrium. So they'll try to change, increase, decrease, and then as we can see from this MATLAB, it is trying to go in some circular fashion and increase as well as decrease. So this is one model that I was planning to discuss with you. I'll also give the MATLAB function. This is just to, give some, visual insight about this predator prey model. It may not be there in the assignment, but I have just given as a, knowledge pin. So there is less than a minute. If this meeting ends, kindly join back. We can end this session over here. If you have any doubts, you can ask. Else we'll wind this session here. I'll try to edit and upload the video by tonight. If not, by tomorrow I'll try to upload. And the notes I'll be uploading to the drive link as I have mentioned in the chat. Please keep those links with you. And if this meeting ends, kindly join back. We can summarize this session and when we can wind up this meeting. Okay, to quickly summarize, in this week we have discussed about the modeling of the systems, mathematical modeling of the systems. So we have started with system and understood what is system, and then we have discussed about the nomenclature as well. Then we have discussed about different classification of systems like linear and nonlinear systems, how to differentiate between static and dynamic systems, what are time variant and time invariant systems, and causal and non-causal systems. And then we have solved few problems and understood the different classification of the systems. And then we have understood what is a control system, closed loop control system. Then we have quickly considered one electrical system and obtained the differential equation. And similarly, we have obtained one differential equation for a mechanical system. And then we tried to compare both, and then we got an analogy between the force and voltage, which parameter in spring mass damper corresponds to what element or what term in RLC circuit. And then we have solved one spring mass damper and understood how to solve such problems and get the dynamical equations. Then we have also discussed about the predator prey model and how the like elements will change. And then we have also seen at steady state what is the population of the predator and prey. And then we have also seen MATLAB code and obtained a physical insight on how the population is getting changed. So if we start with the steady state initial condition, it will be remaining fixed. But if you do not start with the same condition, it will try to change, it will grow and it will come back, and it is happening in a circular fashion. So at some point of time, the population of predator is more, and at some point of time it is less, and same for the prey as well. So I'll share all these notes as well as this MATLAB code, and then I'll try to upload this video because I have to consolidate all these 40-minute recorded lectures, and then I'll upload to my YouTube channel. Please keep the meeting links I have shared as well as the drive link and YouTube channel link saved somewhere so that you can easily access them. And I'll also upload these notes as well as YouTube video within 24 hours. So by tomorrow I'll try to upload, but from the next week I'll try to upload on the same day itself. If you have any questions, you can let me know, else we can wind this session here.
Sir, one thing.
Yes.
Sir, Lotka-Volterra equations, how to get those equations? Is there any how to model the predator prey model? How to get those equations?
Okay, so actually the derivation is not covered in this course, so that's why I have not covered these equations, but you can get any online material. And these are, very straightforward, idealistic equations, but in actual, some, upgraded variations here, instead of alpha x, you'll have a like a second order expression, because ideally speaking, theoretically speaking, if there are no big fish, small fish cannot go or grow exponentially, right? It cannot become infinite. Then the vegetation will go down. So here we have made some assumptions and we try to understood this model. Yeah, but you can always get the material online, but that is not part of this course. So sir has covered this model, because this is also one type of model where you can understand how the big fish and small fish are growing, and how the population of one fish is dependent on the population of other fish, and how dynamically the population is changing depending upon the initial condition. Yes, but you can always look up to the online material and get more insight of this Lotka-Volterra equation.
Sir, I have one doubt.
Yes, yes.
But in this RLC series circuit,
Okay.
we are using DC as a excitation, not in this control system point of view, it is in electrical point of view.
In the electrical point of view?
Yeah, capacitor works in AC only, na sir?
Yes, yes, yes. So here in my input is not DC.
So,
Input is a function of time, V in of t.
yeah, type. Okay. Thank you, sir.
Yes, yes. Yeah, that's a good point that you have raised. So here input is not a constant. Input can be anything, sine or a function, varying function. So that's why we have not made any assumption. We have just obtained the dynamical equation. What will be the capacitance voltage? That depends upon the input voltage. But here we have just drawn the second order dynamical equation. So if it is DC, then you are right. So this will be open. This is shorted. So VC is nothing but V in. Okay, if you do not have any questions, then I will end this session here. Today's session was nice, and I hope all the sessions will be as much interactive or maybe more than today's session. And I wish you all the best for your assignment. If you have any doubts, you can ask me over my mail as I have shared, or you can also ask in the YouTube comment section. I'll try to reply whenever I get time. And I'll see you again on the next week, Monday, with assignment 2. So all the best and do well in the assignment. See you again on the next Monday. If you do not have any questions, then I'll end this call here.
Okay, sir. Thank you so much, sir.
Okay. Yeah. Thank you.
Thank you, sir.
Thank you,
Thank you.
everyone.